What is up, guys? Today I'm going to show you how to decompose polynomials of really high degrees, for example, to the 4 or to the 6, all of this stuff. So it's really easy, actually. So what you're going to do first, right, is you're going to simply do the following. You're going to take, we first have to learn how to do synthetic division. This is called synthetic division, right? And it's really easy. So what you're going to do is basically, we're going to take an example here, x squared minus plus 4x plus 4. And we know that its roots is going to be minus 2 and minus 2. Yeah, we just use the general formula to find this. But I want to just illustrate the example here to show you how it works. The requirement for synthetic division is that you know at least one of the roots, right? So we know that one of the roots is minus 2. So we're going to write here minus 2. Then you're going to write all the values that we have without the x. So that means we have here, for example, we have 1, we have 4, we have 4. So now write those over here, 1, 4, 4. Then you're going to take this number and put it down over here. So you're going to put it down there. And then you're going to multiply this number times this number and put the result here. So we're going to have minus 2 times 1 is minus 2. And then you're going to sum 4 and minus 2, which is basically 2. And do the same thing. Minus 2 times 2, which is going to be minus 4, which results to 0. As you can see, we have the 0 here is a key requirement to know if the synthetic division worked. If by the end of the synthetic division you get a 0, it means this is correct. This can be translated as x plus 2. That's it. You just remove 1 degree of this guy. So you remove 1 degree, the maximum degree is x squared. So you remove 1 degree and then you put it as here, right? Okay, great. Now let's dwell into the freaking exercise actually. So in this case, we want to do synthetic division to this, right? However, we have an issue. We don't know what root we should use. So we're going to just test out some roots. To choose the right values, we do the following formula, which is a QP, the QP test. So you're going to write Q here and P here. And you're going to do here P and Q, right? And then P, you're going to write all the numbers that divide 36. So plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, and so on and so forth, right? And over here in the right, plus minus 1 only, because we only have one value that's 1. Then you're going to take P over Q, and you're going to check for every single P and every single Q. That is, we would check for this 1, plus minus 1 is going to go here, and plus minus 1 is going to go here. And then plus minus 2 here, plus minus 1 here, plus minus 3 here, and so forth and so forth. As you can see, we only have plus minus 1 in Q, meaning we're going to check only basically the values of 1, 2, 3, 4, and 6, right? So what we're going to do is we're going to do synthetic division again. So we're going to check for these numbers. You'll see what I mean. So we have this, right? Now, you have to write this whole equation in its entirety. So that means x4 plus 0x cubed, which is a term we skipped, 5x squared plus 0x, which is a term we also skipped, minus 36, right? You're going to write all of these numbers into a synthetic division. So that is 1, 0, 5, 0, and minus 36, right? Perfect. That is looking perfect. Now, how are we going to check for the numbers, right? Well, we're going to first check plus minus 1 over plus minus 1, which is basically 1, right? In this case, let's try it out. We're going to put 1 down, which is this one, goes down, multiply it by 1, multiply by 1, so that's going to be 1, and then sum it with 0, 1. Repeat the step. 1 times 1, give me 1, 6. 1 times 6, 6. Plus 0, 6. 1 times 6, 6. plus minus 36 is going to be minus 30. As you can see, the last term is not 0, so 1 does not work in this case. So let's check minus 1. In this case, I already know it's not going to work because I already checked it. So let's try 2, right? Let's try 2. So do 1. 2 times 1 is going to be 2. 2. 2 times 4. So 2 times 2 is going to be 4. So it's going to be 9, right? Then 2 times 9 is going to be 18. 18 times plus 0 is going to be 0, well, 18. 2 times 18 is going to be 36. And check this out. We have 0. Wow, this is amazing. What does that mean? It means that we have that this basically works. So we're going to take our x, in this case, it's the fourth. So we're going to write it now with it x to the cube, so minus just one term lower. So this is going to be equal to x cubed plus 2x squared plus 9x plus 18. And that's basically what we have. As you can see, we have x that. So that means x equals to 2, one of the x's. We repeat the process, right? In this case, I'm not going to repeat the process because my calculator can do that for me, even. So let's check this out. Obviously, if you cannot use the calculator, you have to repeat the process up until you get to x squared, right? Actually, let's do that before we even use a calculator. Let's do it by hand. So, as you can see, we have this whole chimichanga, right? And we're going to repeat the process, right? Q, P. We know that P is going to be plus minus 1, plus minus 2, 3, 4, no. Is it 4? No. Plus minus 5, no. Plus minus 6, right? And Q is going to be basically plus minus 1. So again, P over Q is always going to be our number that's on Q, right? So we do the same synthetic division here. Oops. If you're quick with this, it's quite easy actually. So now 1, we're going to write our values 1, 2, 9, 18. Now we're going to write here plus minus 1. Let's check plus minus 1. So we check for 1, goes down. And this will not work because we have no negative numbers. We need a negative number at least. So let's check the negative number. So it goes 1. 1 times minus 1 is going to be minus 1. So minus 1. No, it's going to be 1 again. Minus 1 times that is going to be minus 1. So that's going to be basically 8. Then, minus 8. That's not going to work. But I'm willing to think that minus 2 will work. So let's check it out. 1. 2 times minus 2 times 1 is going to be minus 2, 0. And 2, 0, 9. And then minus 18 and 0. As you can see, this works. So we're going to take this and write it. X squared plus 0x plus 9, right? In this case, we have x squared plus 9, which we can simply now just solve as we normally do, which is going to be, oh no, that doesn't work. Well, yeah, actually it does work. There's going to be minus. And that basically means we have 3x4. This basically means we have 3i and minus 3i, and then x squared is, well, x2 and x1. x1 we already found is 2. The other one is minus 2. And these are our roots, basically, right there. So yeah, that's how you do it, guys. You guys can also check it out with a calculator and stuff. If we even check it out with a calculator, we can do that. So I'm going to show you how to do that. So you take the calculator here, you go to menu setup, and then you're going to do, well, you can always like travel it like that, but I already know where it is. So it's here, right here is an A, which is function equation. So alpha A, and then do polynomial, and then do whatever degree it is. So in this case, it's 4, right? So we go back to original function, which is this guy. We can simply write it in here. So we can do 1 right? 0, and then 5, and then 0, and minus 36. 2, minus 2, as we can have here. Then we have 3i and minus 3i, as you guys can see. Obviously, this is like just to check, or if you're in just a trouble, you can always do that. But honestly speaking, you can always check with this, and it's way quicker, no? So yeah, that's how you solve these type of exercises. When it comes to like x to the 6th minus 1, again, if you're gonna do synthetic division, you're gonna write all the other values. So you have x to the 6th minus 1. This is gonna be equal to x to the 6th minus 0x5 plus 0x4 plus 0x3 plus 0x2 plus 0x plus minus 1, right? So you're gonna write all of these. So you're gonna do basically 1, 0, 0, 0, 0. How many zeros is it? 1, 2, 3, 4, 5, 5, and then minus 1. In this case, it will not make that big of a difference because, it's just a bunch of zeros. But sometimes you have numbers in between, just like in this case, as you guys can see here. And it's important to have the positioning correctly. So yeah, that's how you do it, guys. Again, thanks for watching, and I'll see you in the next video, I guess.